Hi everyone, welcome back to Information Economics. Today we will talk about a problem related to the forecasting decision at the retailer side. We will talk about a supply chain with a manufacturer and a retailer. That manufacturer may try to offer incentives for retailers to do forecasting or not to do forecasting. Okay, so there will be multiple players involved. There will be the supply chain contracting issue. There will be channel coordination issue, and there will be private information. So I think this particular lecture would be a good wrap up for all the materials we have introduced in the first half of this semester. Okay, let me start. So in this video, I will talk about the introduction of the research question, and then we will talk about the model setting, and in particular, we will talk about how the two kinds of contracts, rebates and returns, may be used for inducing or discouraging retailer forecasting. Okay, we will talk about the problem in today's lecture. So let's talk about demand forecasting. We know in general, in a supply chain or in any supply system, supply-demand mismatch is always a big problem. This simply means you cannot fully predict what will be the demand. So you face an inventory decision, just like, for example, the news vendor problem. You want to store exactly what will be at the demand level, but of course that's impossible. You always face some stock out and some leftover. So that's always supply-demand mismatch. As a company, they may try to do forecasting so that they may better understand the demand, and then they may be able to minimize or to reduce supply-demand mismatch. Okay, so forecasting is definitely something that in practice firms try to do. In a supply system or a supply chain, obviously it's more reasonable for the retailer to do demand forecasting. Okay, sometimes the manufacturers also do demand forecasting, but almost no retailer choose not to do forecasting to some degree, right? Because the retailer is the one that is forecasting, that is facing consumers, facing the market. The retailer is the one that makes the order decision, the stocking decision about how many products to put on their shelves, on their warehouses. So the retailer is really the guy that face the most serious supply-demand mismatch problem. Okay, and for the manufacturer, sometimes he does not need to do any forecasting. If at his side the problem is just a make-to-order problem, or it's also possible that the manufacturer is just an expert about producing products and it has nothing to do with the market. Okay, so more likely the retailer is the one that can choose to do forecasting. In that case, the manufacturer may only try to incentivize or induce the retailer to do forecasting. Why? I should say why the manufacturer may need to do that is typically because the retailer is the one that pays for forecasting. If the retailer wants to do better forecasting, he may need to, for example, buy more advanced information systems. He may need to train their salespersons or train their market analysts with modern forecasting techniques and so on. Okay, the one that does the forecasting is the one that pays the cost. So if the cost is so high, the retailer may choose not to do that. And then if you are a manufacturer and you prefer the retailer to do forecasting, then you may need to, for example, pay the forecasting cost for the retailer or something like that. So the manufacturer may only induce the retailer to do that. It's always impossible for you as a manufacturer to ask, to require the retailer to do forecasting. That's impossible. You can only try to induce or incentivize the retailer to do that. So here we can say that whether to do forecasting is the retailer's hidden action. Okay, or we say there is a moral hazard problem. The manufacturer may or may not observe whether the retailer does the forecasting or not. But in any case, this is non-contractable. So the retailer can treat this simply as a hidden action, and then the manufacturer somehow need to provide incentives for retailers to do this or do that. We will study how the forecasting cost affects the supply chain. Okay? Obviously, if the cost is small, then it's easier for the manufacturer to induce the retailer to do forecasting, or otherwise it may be hard. We will study how this cost affects the supply chain. We want to study whether it is always beneficial to induce forecasting. This problem may be answered at the system side, or at the retailer side, or at the manufacturer side. As a manufacturer, you may ask yourself whether you want to induce forecasting or not. There are obviously many different outcomes on whether there is a forecasting action affects the system in many different perspectives, and here are two of them. If the retailer does forecasting, then the retailer or as a system as a whole can reduce supply-demand mismatch. From the system's perspective, the system basically will become more efficient, so the total channel profit would become larger. Okay? But that does not mean the manufacturer can also earn more, because in that case, as long as the retailer forecasts, the retailer will get some market knowledge or get some market information, which will be privately observed by the retailer. So once the retailer does forecasting, the manufacturer will be at information disadvantage. There will be information asymmetry in the channel. Okay? So we want to ask whether it would be beneficial to induce forecasting. And if forecasting is beneficial, when should the manufacturer do that? And what is the most efficient way for the manufacturer to do that? That's the problem. So we will talk about how different kinds of contracts may be offered by the manufacturer as some kind of incentives. Okay? The only way that the manufacturer may affect the retailer's decision is by offering some contracts. In particular, we will talk about rebate contracts and return contracts. In previous lectures, we have introduced these two kinds of contracts, and also there are others, right? There are others, but here it's reasonable to focus on these two contracts, as we will tell you in a short time. These two contracts are somewhat opposite if we consider the retailer's forecasting decision. So, what are them? Under a rebate contract, the manufacturer pays a bonus to the retailer for each unit sold. So that means when you sell some product, you will earn more, and part of the earnings comes from the manufacturer. That means a rebate somehow encourage the retailer to do forecasting, right? Because by using a rebate contract, you are requiring your agent, you are requiring your retailer to become more accurate, because the risk of facing a supply-demand mismatch becomes higher. So once we offer a rebate contract, basically the retailer will have more incentive to do forecasting. On the other hand, if we offer a return contract, then the manufacturer will buy back unsold units, and that means the manufacturer offers an insurance to the retailer, and obviously the retailer will have some incentives to not to do forecasting. Okay, so it's interesting to compare these two contracts in this demand forecasting problem, in about how these two kinds of contracts affect the retailer's decision and which one is better than the other in general. Okay, so the manufacturer's problem may be which contract format is more beneficial, and for example, may maximize the manufacturer's expected profit. The study we introduce here has been done by Taylor and Shaw in this particular paper published in Management Science. Okay, so basically we are talking about this paper. Let me introduce more about the demand forecasting, or about how this paper talks about demand forecasting. We will say there is a manufacturer and there is a retailer, and these two guys both face uncertain consumer demands. So if the retailer does not do forecasting, then their knowledge about the market will be the same. There is a unit production cost C and a unit retail price P. Okay, so these are just basic assumptions. Without forecasting, both of them think that the random demand is a random variable Dn, and that follows a cumulative distribution function CDF as f of n. Okay, so just to help you remind yourself, f of n x means the probability for your random demand to be less than or equal to small x. Okay, this is your CDF. If you decide the CDF, then you decide the distribution of this random demand. The retailer may do a forecasting with a forecasting cost K. That means if you do forecasting, you pay the forecasting cost K, and then the retailer will obtain a private demand signal denoted as S. S may have two values, either H or L. H means something that is optimistic, and L means something that is pessimistic. We will say that it's a high signal or a low signal. It's something like you do a market survey about, you simply randomly select 1,000 potential consumers and ask them, how do you like this product or not? And then, according to their responses, you make some conclusions about whether the market condition is good or bad. Before we do the forecasting, we expect that with probability lambda, we will see a good signal. That's going to make the retailer optimistic. And then she will update her belief about the random market to another random variable dh with another CDF called f of h. Otherwise, with probability 1 minus lambda, the retailer is going to see an unfavorable signal. And then the retailer will become pessimistic and use another random function, random variable dl. We will assume that if you are optimistic, then your CDF fh would be smaller than fl. Keep in mind that fh tells you the probability. So for the probability for the demand to be smaller than x, fh is always smaller. So that means your demand is basically higher. And also, if you don't do forecasting, then your CDF should somehow be the combination of your high CDF and low CDF. Okay? Before you do forecasting, this is the only thing you can expect. You know the demand may either be high or low with these probabilities, but you just don't know whether it's high or low. You can do that only after you do the forecasting. Okay? So before forecasting, your demand function is Fn, and after forecasting, it will become either Fh or Fl. We will assume that capital F is strictly increasing for any possible demand function. Now let me write it as Fs. And also we define something called the inverse, I should say the 1 minus Fs of x as the right hand side, as the right tail probability of a CDF. So to give you more concrete ideas, let me provide a very simple example. Suppose we know that according to our past experience, if tomorrow is a rainy day, demand would be zero and uniform between 0 and 1. If tomorrow is a sunny day, it will become uniform between 0 and 2. Okay, that means they have their CDF like this. So let me try to draw it. This is 1, this is 2, and then for FL, it's something like this. Okay, this is FL. And then for FH, it's something like this. So you can see that FH is always below FL. Okay, that's the idea. And then we may say that the demand is simply depending on a random number theta. Theta decides the upper bound of the demand distribution, and theta may be either 1 or 2. And then lambda would be the probability for theta to be 2. And 1 minus lambda is the probability for theta to be 1. If the firm does not know theta, then all we can do is to somehow do a linear combination and form the no forecasting demand function. It will simply be, for example, something like this. It may be anything looking in this shape within this triangle for different values of lambda. Okay, so this is just a very simple example about you have FL, you have FH, and you have FN. Okay, and this is just about demand forecasting. Before you do forecasting, you think it is in this way. After you do forecasting, you know it will be either FL or FH, and that's going to help you to do some ordering decisions. So let me summarize our research questions. Should the manufacturer induce the retailer to do forecasting? If so, how should the manufacturer design the offer? Which type of contracts, returns or rebate, is more beneficial for the manufacturer? And in any case, or under any equilibrium, we talk about efficiency, inefficiency. We talk about the incentive issues and how information asymmetry affect their behaviors in this particular problem. Okay, so that's the introduction of this problem. Thank you.